Hello and welcome back to another video. In this problem, we're asked to use Formula 10 to graph the given functions on a common screen. So what is Formula 10? Well, in this particular textbook, Formula 10 refers to the change of base formula. So that's log base b of x is equal to ln of x over ln of b. And what we're going to do is we're going to use this to turn all of these into different fractions and then graph those fractions in Desmos. So log base 1.5 of x equals ln of x over ln of 1.5. If you don't remember which one has to go in the numerator and the denominator, right? If you can't remember this expression perfectly, all you have to do, base goes in the bottom. So the natural log of x is log base e of x. So this is ln of x over ln of e. Natural log of e is 1, so this is just equal to ln of x. And obviously that makes sense since that's the original function, but I just wanted to use Formula 10 anyways, but all we have to graph is ln of x. Log base 10 of x is equal to ln of x over ln of 10. And log base 50 of x is equal to ln of x over ln of 50. And so these are the four equations that you have to graph. And what I've done here is put them into Desmos. And we can see that these are all just different log functions, which makes sense. But thinking about it in terms of how we actually calculated them might give you an idea of why the change of base formula works. So, excuse me, these are all the natural log of x, which we have in purple here, divided by some value. And so you see the compression that we have here, right? Because going back to our transformation section of this textbook, dividing by a different value is equal to multiplying by 1 over some value, which means you're doing a vertical stretch, or a vertical shrink rather in this case, by a factor of whatever this is, right? So here, it's dividing by ln of 1.5. Log base e of 1.5, since 1.5 is less than e, is actually a fraction, right? It's less than 1. So if you're dividing by less than 1, that means you're multiplying by a number greater than 1. Therefore, this isn't actually a stretch for this case. It's not a shrink in this case, it's a stretch to this function right here. However, when you get numbers like ln of 10 and ln of 50, which are what these functions are being divided by, then you can see it's a stretch. Right? If I look up, I don't know if you'll be able to see it, but ln of 50, right? ln of 50 is just a little bit less than 4. So this is a vertical stretch by a factor of 4. I think this is sort of helpful not only for being able to graph these functions when not every graphing software is going to be able to let you put in a custom base, right? Everything's going to have natural log. It also shows how these are all related because they're just the transformations of a single function, ln of x.